Hey everybody, this is OpenCV with Python. What we will be doing today is how can we use OpenCV with Python. We'll be doing a very simple example. So I was working with a project and I needed to use some draw functions with OpenCV to kind of represent a table tennis table. And so what we will be doing is how can we draw a table tennis table with the functions available in OpenCV. And we'll start by I had empty repository, empty directory here. You might want to install OpenCV, and there are multiple ways to do this. You could just go ahead and say pip install OpenCV Python, if I'm not wrong. Then you've got OpenCV contrib Python, and then you've got OpenCV contrib Python headless mode. So if you're on a server, if you run these systems, your code on a server, which may not have a GUI toolkit, right? Maybe Qt or some other toolkit, you might want to use headless to get it working, right? So if you install OpenCV contrib Python and your scripts are not working on a server, this might be the issue. So I have OpenCV installed, right? I'm going to create a file called drawtable.py, right? And we'll have a very simple function. So I'm going to say we'll just import OpenCV with OpenCV as import CV2. Some people use import CV2 as CV is just an alias to this. I'll just go ahead and use OpenCV2, right? And we do need NumPy, so I'm going to say import NumPy as NP, and we'll start from there. I'll just write some dummy codes. I'll just write the function as f and pass. We'll say if you do not necessarily have to do this, but then if you're, if this code is inside your project and you just want to run this only when this file is called, etc., etc., so this will do the job. And there you go. We have pass, and if I do this, we shouldn't see any errors. And we'll just run these, and we have no errors. So the first thing I'll just write some documentation, right? So one thing is if you're a beginner in Python and you want to kind of think what does this function do, and this is a good way to kind of start. And you could just write, hey, this is the doc string, or this is the documentation for the function. I'm just going to note down what this function does, right? So basically, it's going to do is create a dummy image, right? So and I'm going to create that with NumPy. So I'm going to say using NumPy, and I need to draw a rectangle representing the table. That's rectangle representing a table, and I need to draw the center line. So a table tennis has a vertical and a horizontal center line. So I'm going to say draw vertical center line, and I'm going to say horizontal center line too. And then just write the image to disk, right? Write the image to disk, and there you go. And that's pretty much it, right? So we'll just improve our documentation as we start writing our code. So the first thing is to create a dummy image using NumPy. I can just do that using, let's say, an image equals np.zeros because I want a black image. I'm going to share that, and the shape is, let's see, I'm gonna say it's 800 as the width. I think now it's the height, and then 600, and the channel is basically I need a color image. I'm going to say it's a three channel image, and then I need the d type, the type to be, let's say, np.uint8, and that does the job, right? And what I will do is I'll just write the code to write the image to this so we can see the output. So I'm going to say cv2.im write. I'm going to say table.jpg and give the image array, right? So we'll just run this and see what happens. So I'll just say Python 3 draw table, and we have it. I'll just open this, and there you go, right? We have a test image like that's black in color, and so we'll move forward from here. So I have this, and the next step is to draw a rectangle representing a table. So when we draw a rectangle, so we use the cv2.rectangle function, right? So if you're a beginner, right, you can just write the documentation and run your thoughts through here, And so so I know, okay, I'm going to use the cv2.rectangle function. And if from the documentation, I know that the two or one required item is the image itself. So we have the image here. We have created that, and I need the the top left corner coordinate, edge, right? You can say edge, and the bottom right corner edge, right? So that's basically what OpenCV is expecting for us to pass. Then we need a color and a thickness, right? Thickness parameter, and this is what I'll do. So the top left, I'm gonna say my image width is 600. So I'm going to just say I'm going to start from 50. That's my initial exposition. So I'm going to say x equals 50, and I'm going to give an offset from the top two. I'm going to say y equals 50. So that kind of becomes my top left edge. So that would be x comma y, and my bottom right corner. So the bottom right corner would be what? So the x direction. In the x direction, if you look at this image, we have 50 as our offset plus the width of our image, right? Width of our table. So there is some calculation we need to do before that, right? So I'll tell you why. So let's just assume the length of the table is 700 because we have the 800 as our height, and we're drawing the table in a the vertical orientation. So let's assume the length is 700, and the width is something that will depend on the ratio of the table, right? And a table tennis table. So table tennis table size is going to be, the length is 274 centimeters, and the width is, I kind of need to check that. So I'm gonna say table tennis table dimensions. So that's 274 and 1525. So I want say 152.5, right? So I'm gonna say 152.5, and that's kind of the table tennis table size, not the size, it's the length by width ratio, right? So that's the length by width ratio. And so the new width would be what? It would be the current length divided by the ratio, right? Or let's say table ratio, right? And I can just take this code and let's just put it here. So we need to calculate the bottom right edge corner. And so in here, the bottom right edge corner, x would be what? So the x would be the initial offset, right? X would be x plus, let's say, just to understand, let's say the x is just offset plus the width of the table, right? And in the y direction, that would be again the y offset. So let's just say y offset, and we could say x offset, right? It's basically 50, which is what we have defined here, right? And y offset would plus the length of the table, right? And so we kind of know, okay, that is the coordinates. And if I were to kind of do this, let's just do x comma y. So we have this, let's say, let's just put x1 and y1. So I'm going to say x1, y1, which is x2 and y2. And so this would be x, and this would be y, or just say, sorry, x1 and y1. And I can just take these and put in my code. So I can do this, and I need the table ratio there. So the table tennis ratio would be this. I will fix that in a minute. So if I go down, I have the ratio there, and table ratio, cool, that's equal to there. And the width, I need the integer kind of, we need integer type for passing into a rectangle function. And then I need the x1 and y1, which is this. I'll just need that, and I can remove that, right? So we go x2 equals x1 plus that, and we have our coordinates, right? So if I do this cv2 rectangle, I have the image img, and then I'll pass the x1 comma y1, and I'll say x2 comma y2, and I need the color, right? And the color value is going to be, let's just pick a table tennis color, table color in RGB. So I need to RGB, let's just take RGB, table tennis table. Let's just find this. Okay, it's not actually a table tennis color that we are getting. So, okay, let's try and get this. Okay, so we can use this, right? So this is RGB. We actually need BGR. So we'll just copy just this. Okay, and so we need to put 126, 6 here, and this was 70, so also 126, and put 70 in here. And the thickness, I'm gonna say, let's just put 1, right? So just 1, and close that off. And so if we just write that, we have already written the code to write this, and if we just run that, let's just see if we have any errors. No, we'll just open that table dot this. Okay, so we have a color there. And okay, so we did one thing, we did one mistake, right? So what I'll do is we'll fill it with this color, right? And to fill it, we provide the thickness as -1, and that kind of solves that. So I'll just open that again. So we have that color, like so. I'm not sure this is the actual color. Like there is green and blue tables mostly, but then let's just assume this is a color, and let's just move on, right? And if you look at this, right, we have a color, but then table tennis tables have these white edges. So what I'm going to do is draw one more rectangle on top of it, but use the border or the thickness instead of -1, right? So I'm going to copy this. I'm going to say 1 and change the color to white. So I'm going to say 255, 255, 255, and I will run that. And we have no errors. We'll just open that, and there you go. So you can see a slight white background. We can increase the thickness by saying this as 2. I'll just run that again. And okay, this looks kind of better than the previous one we had. Now, the next thing we need to draw is the center line, so the vertical center and the horizontal center line. So that's what we'll do next. So let's try and figure out the coordinates for the vertical line. So the vertical line has the same x coordinate, right? So if you look at this, let me show that again. This is the line that we're going to draw, and the vertical line basically has the same x coordinate, and which is the x offset plus the table width by 2, right? So we just defined that here. So we're gonna say, let's say x3, right? Let's x3 as x1 plus the width by 2, right? And then if we look, so and just do x4, even also has the same, right? So I can just copy that and say x4, just move that, and we need y3 equals something, and need y4 equals something, right? And basically y4, okay, just do this. There you go. So we have y3 as our this, and if you look at this coordinate, the y point is basically the y offset, right? I'm gonna say y1, and if I do y4 is basically y1, or the initial offset plus the length of the table, right? So I can do that. I'm gonna say y1 plus length, and that's it, right? So basically we have the line coordinates as x3 comma y3, and I'll just use an integer here, so we better make sure that we're passing an integer type, and we have, it's going to be x4 comma y4, and we'll just copy this and paste it, right? So it's kind of makes your thought process easier, so you're not actually coding, you are making sure like everything's right. So okay, I can just remove, I'll just not remove, I'll just keep it there. I'll say cv2.line is the function that we'll use. We pass in the image, and we will pass in the 2 points that we have, which is x3 comma y3 and x4 comma y4, and just use white as the color. So I'm gonna say 255 comma 255 comma 255, and the thickness, let's keep it as 2. And we kind of basically have the same line except for the difference in coordinates, and we will define that. So we'll just confirm that this is working, right? So what I'll do is I'll run this. Okay, that's j is not defined. Okay, that's a mistake from when I was typing. Okay, so we have that. Okay, there you go. We have a center line in the vertical center line. I'll just draw this horizontal center line and kind of finish our example. And so if you look at the horizontal center line, the x direction is basically the x offset, which is No, so okay, so the y is the y direction that's it, right? The y is basically y plus the length by 2. So we'll just kind of write that. So what we'll do is what we have is x5 equals something, y5 equals something, x6 equals something, and you could just give you any names you want and say y6 equals something. And if you look at this, the y is practically the same. It's y1 plus the initial offset plus the length by 2. So I'm going to say int of y1 plus length by 2, and I will put in a bracket so that we get computation correctly. And I can just copy this to y6 because it's the same, and it's the only difference is in the x. And for y5 is this point here, which is basically the x1 offset, and for x6 is basically x1 plus the width of the table, right? So I'm going to say x1 plus width of the table, and we can actually use this now. So I'm going to copy this. I'm going to put that here. Oh, sorry, not there. It's beneath this line. And let's just use x5, y5, x6, and y6. You could easily make this code much less, right? You can just hard code all the coordinates there, or you don't have to use x1, y1. I just used it to kind of make the thinking process easier. Okay, and I think we're done there. Let's just try this out. Okay, we have no errors. We'll just open, and there you go, right? We have drawn a table tennis table. You can always use, make it look better. You can have, some, maybe you need to do some highlighting process, and you can always make, draw some random stuff here to indicate the net of the table, etc., etc. Now, this was a very brief introduction on how to use OpenCV with Python. Thank you for watching.